Okay, so we're going to start with the topic of matrices. Now, a matrix, as it says there, is a rectangular like bracket thing that contains information, or it can be numbers, it can also be letters. So what we're saying is a matrix, it can look like this. So you could have two, so it's a square, you've got these square brackets, and it contains information. But we're saying we can put letters in there as well. So when they say pronumerals or something, we could have a letter matrix. And now they can be all different sizes as well and shapes. So, I could have a matrix that looks like that and so on. So normally we give a matrix a label. So we might call this one, we'll just call it, we're calling it matrix H. And they often use a capital letter. And it's just so that you know which one they're talking about, or so they don't have to write it out every time. So when they can say, just we're referring to this matrix. Okay, so you can see here, this example here, they've called this matrix A. And what it has, when you've got the numbers or the letters inside the matrix, that's called an element. So see here, these are all elements. So this matrix actually has 6 elements apart. So up here, this one has 4 elements in it, and say this one has 3 elements, okay? So sometimes we want to go and talk about a particular element. So we sort of need to be able to describe our matrix. And the way we describe like the shape of the matrix is the order. So you might write a little note that the order equals we might use the shape of the matrix. So the way you describe the shape of the matrix is that you say how many rows it has by how many columns it has. So often we just say it's in that format. So up here, this has like say row 1, row 2, and this would be column 1 and column 2. So this one is a 2 row by 2 columns. So it would say a 2 by 2. What do you think this one? How many rows has this one here got? It's got 1 row. And how many columns has it got? 3. Yeah, so it'd be a 1 by 3. So when they ask you for the order of the matrix, you just have to say the shape of it. So up here, this one has 3 rows and 2 columns, okay? So you've got to just remember that you've got to do rows first. So, so just remember that. So we have the rows and now we know the elements. So say I have this matrix, I'm going to write it out again. So we've got this matrix A here, and it has 6 elements there. And we want to tell you, if they want you to go look at a particular element, or they want you to, they might ask you what it is. What they do is when they're referring to a particular element, they'll use the little letter. So that means to go to the matrix A. And then what they do is they refer to it as I and J, where I equals the row number and J equals the column number. So here, when they say to go to A3, 2, that means I'm going to go to row 3. So see this, row 1, row 2, row 3, and I'm going to go to column 2. So, and then I go to column 2, which this is the columns up here. So column 1, column 2, so I'm going to row 3. So they want me to say, or, it's -4. If they ask me what element that is, it's -4, okay? So here, this is taken out of an exam question in Year 12. But it's to help you, the more you do these this year, the better you're going to go. Yeah, because this one, it's time consuming. So the better you get at it, the better. So here they've got the matrix M here. So we can see we've got matrix M. And what's the order of matrix M? Can you guys tell me this? It's got, it's a 2 by 4. Good. So we've seen 1, 2 rows and 1, 2, 3, 4 columns. That's why we're saying that. Now, what they're saying is here before, they're saying the element in row I and column J of capital M is MI. So what they're saying here, this is just a way to say that I equals the row number and J equals the column number. Okay, so you will get that in every year 12 question like this. They're going to write that statement so that we know. So what they're saying is we have to find, they've got all these rules to make this matrix here. And they're saying, which rule works. So if you have a look here, they're saying if I test out this rule here, I'm going to do this one. They're saying the way I find, so if I set up this matrix here, this is matrix M, and this would be row 1, row 2, and this will be column 1, 2, 3, 4. So this spot here is actually I equals 1, doesn't it? And J equals 1. Is that true? Because it's in row 1, column 1. So this spot here is still I equals 1, but J equals 2. Does that make sense? Yeah? And then so on. So what we're looking at, and so we've got all these spots. So when we get this rule here, they're saying the way I create this matrix, if I was using this rule, is I go, if I'm in this spot, I get the row number and I add the column number. So say I'm doing this one here, I would go, the row is 1 plus the column is 1 and then minus 1. So what do you do? What does that equal when you do that? 1 plus 1 minus 1. Is it 1? Yeah? So that would put a 1 in there. And that's what they've got. So at the moment it's working, isn't it? Yeah, this rule works for this. But let's go test another one. Let's test down here, this one. Now this one would be what? It's I would equal what? It would equal 2 and its J would equal 4. So if I did this rule, the I plus J minus 1 rule, it would be 2 plus 4 minus 1. What does that equal? 2 plus 4 is 6, plus minus 1 is 5. Now, is that what's there? No. So this rule, we'd eliminate it. It's not that one. So can you see, we'd have to go through all of them and test them out. So I'll leave it there. This is a challenging question, like it takes a long time. Very tedious, isn't it? So I'll leave that there and I'll get you guys to have a go and see if you can work it out like later, okay? But so we've got these matrices and we now know we can describe them using, or their order, their shape. And so now we just need to know some like basic matrix shapes. So if we have a row matrix, can you see its order is a 1 by 4. So what do you notice about a row matrix? It just will always have just a 1 row, yeah? So then obviously with the column matrix, yeah, we only have 1 column, okay? So it's pretty easy. If you've got a matrix that just has 1 row, it's a row matrix. If you have a matrix that just has a column, it's a column. So why do you need to know this? Is because they'll probably say, here's some information, write it in a row matrix. So it means you have to write it across like that. Or okay, so they'll tell you how to write the data. Okay, so then it's a square matrix. What do you notice about the square matrix? What makes it a square? Yeah, so the rows are the same as the columns. Yeah, is that true? Yeah. So if I have a 3 by 3, that's also a square matrix. So say I had that, or matrix like that, that's a square matrix. So the rows, you've got 3 rows, 3 columns, it's a square. Now, a diagonal matrix has just non-zero elements on the leading diagonal. The leading diagonal is when you start up in the top left-hand corner and it goes down on a diagonal and you end there. So see how there's only like non-zero numbers on that part and everything else is 0? That's a diagonal matrix. So up here, this one up here, this is called the identity matrix. Now you can see it has it is a diagonal matrix as well because it only has ones. So it's a special diagonal matrix which just has ones. So another type of identity matrix, as long as it's square and it has the ones down there, that's another identity matrix. Or if I had a 4 by 4, so like that, and if I have the ones along that leading diagonal, that's also an identity. So the identity is like a number 1 in matrices, like a number 1 in matrices, okay? It just can help you problem solve if you think of it as a number 1. All right, and a null matrix has zeros. That doesn't really come up too much. And 2 matrices are equal. So a matrix is only equal if it looks exactly the same. So see, if I wrote this matrix out like this, the only matrix that is equal to that is if it's exactly the same. So it has to have exactly the same. So even if the numbers are moved in a different spot, it's not the same. So it has to literally be equal to look the same. So I could say it can be like a row. I can say as long as it's exactly the same. Yeah? And that's equal.